All right, so here's the deal. This is the second half of chapter 8. The first half is balancing. Y'all are pretty good with balancing. You don't have to worry about it. The second half is going to be able to write the reaction. You've kind of already seen part of it with a word equation the thing we did last Friday. So what you're going to have to be able to do is take a word equation and write the formula from it. But there are several special type of reactions that you have to know. And there are 7 of them. We're fixing to talk about 2 of the 7 today. But before we begin, I want to show you all 7 of them to begin with. Number 1, up here you can actually see it on it. Have it cut off. What's number 1 on the sheet?
Synthesis.
Okay, synthesis. Now look for the line that goes all the way across the front part. It's almost at the very bottom. What's number 2? Okay, decomposition. Flip on the back. Look for number 3. Okay, single replacement. What's number 4? Double. Now, I want to go ahead and show you this and tell you this. If you're reading in a book or you see it on a worksheet or you see something that I've pulled other resources, you may see the word displacement versus replacement. What does displacement mean? To take it out. Replacement means what? To put it back in. So it's interchangeable. So if you see replacement or displacement, it means the exact same thing. I use replacement because you're swapping things. You're not taking anything out. What's number 5? I think, or did I skip 4? No, yeah. 5 is combustion, which we've talked a little bit about. We're going to get a little bit more in depth. 6, acid base. We'll get really in depth into acid base. And then finally, the last one is redox. All right, that's going to be a whole day worth of topic is redox. But today we're just going to cover the first 2. Now, I will go ahead and tell you that you see 8 synthesis reactions listed, and then there's another 1, 2 beneath that. You're going to have to know 6 of the first 8 and 1 of the ones at the bottom. All right, and I'm going to tell you which 6 you have to know. But before we begin, synthesis. You music people, what does to synthesize mean? Okay, to bind, to make, to mix, to produce, essentially. So your woodwinds have to mix with your brass has to mix with your percussion has to mix with your strings, and everything has to come together to synthesize to make the right sound. Otherwise, you sound terrible. Okay, so it's a mix. It's a synthesizing of different sounds. But that's music. What does chemistry synthesizing mean? Read what it says. 2 or more elements or compounds may combine to form a more complex compound. So essentially what we're going to do is we're going to take A and we're going to take B, and what are we going to do? Make AB. Okay, that's what we're going to do. We're going to take A, take B, we're going to put them together and make AB. So we're going to make one thing. So we're going to produce one compound out of this. Now, something very specific that I want to talk about. Does it matter what order A, and in this case X, is written in? Yes, very much so. What is always written first in an ionic compound? Very good. Please write this down. If it's ionic, okay? If it's ionic, that's the first thing. Okay? Cation is written first. Now, what is the charge of the cation? Positive. Now, it is positive. What type of element? A metal or a non-metal is always positive. Metals. Please write that in. All right. Again, that's only if it's ionic. We're not going to really talk about covalent. So what leaves to be written second? The anion is second. All right, what is the charge of an anion? Negative, very good. So we have a negative anion. And now that we already know that metals are cations, what are nonmetals? The anions, very good. So the nonmetals are always going to be written second. All right, so that's a nonmetal. Everybody okay with that? Make sure you write that in, please. Corey, make sure you're writing this in. All right, so let's go and let's look at our first specific type of reaction. So the first one, metal, okay? Doesn't matter what metal it is. It can be group 1, it can be group 2, it can be a transition metal. Any metal, when you mix it with oxygen, will make a what? Metal oxide. All right, so we're going to make a metal oxide. First of all, how do you know that this is an ionic compound? You're exactly right. It's a metal and a non-metal mixed together. Now, my first question is, why is there a little 2 right here behind oxygen? Very good. So write a little arrow out here and say O2 is a diatomic. So essentially what that means is that oxygen will never be alone. Okay? It's one of those needy people. It needs someone to hang out with. It can't ever be alone. Now, once it makes a chemical bond, does it have to have its 2? No. This is what I need you to get. Where did the 2 go when we went with magnesium oxide? What were you saying? No. Say it again. Why did it cancel out? Perfect. So this is what I want you to write down. God bless you. If you write a new compound, this is very important. If you write a new compound, you have to do something. What do you think it is? That's coefficient. You have to, how do you do that, though? Check the... No. Charge. Very good. Wherever you can fit it in. You're going to check the charge. Or charges, plural. Charges. You're going to check the charges. Whenever you write a new compound, you're going to check the charges. Very important. Because it's magnesium. Did you have magnesium oxide on the reactant side? Nope, it's a brand new compound. So what I'm going to do is I'm going to clear this for a second. I'm going to rewrite this. Do I need to put it back up? If you write a new compound, check the charges. You got it? Tyler, you good? Okay. All right. So this is what I'm going to put right here. Magnesium is in what group? 2, so it's a what charge? 2 plus. Oxygen is always a 2 negative. So what's going to happen to your charges? They're going to cancel. Right? All right, Jack, give me any group 1 metal. I don't care what it is. Any group 1. Very good. Let's just pick sodium. Now, group 1 metals have what charge? A +1. Oxygen is always a... So what would its new formula be? Na2O. Thank you. It just said it right there. I'll take care of it. Thank you, sir. So the question is, does it matter what metal it's mixed with to determine the chemical formula at the end? Yes. Because what if it was iron 3? Would that be different? Yeah, it'd be Fe2O3, right? So it just kind of depends on what that is. All right, so put a star beside number 1. You're going to need to know this one. I have good news. Number 2, just put a little X beside the number 2, just like this. You are not going to have to know this one specifically. I'm not going to test you on this one because it varies. It varies a lot in terms of what are you really going to make, because it just depends on what you're mixing it with. But the only thing that I do want you to know is that a non-metal plus oxygen yields a non-metal oxide. And what is this kind of reaction? What's it going to produce? It's going to produce a covalent. How do you know it's a covalent molecule? Okay, because both of these are 2 nonmetals. That's the only thing that I want you to get out of this. Okay, so they're 2 nonmetals. Say that again?
Isn't there like 2 metals that... Isn't it any good anytime to go get metallic salts?
Sure. Okay. All right. Put a little bitty star beside number 3. Yeah, a little bitty star by number 3. All right. Now, I've already told you this. You know all of the diatomics, right? The gun and the bullet, the diatomic gun. But there's another one that I taught you last Friday. It was 2 new ones. It was a special one. One of them was sulfur. When you write sulfur, what must it always have? It's an 8. It's even more needy than diatomics. So sulfur is one of those girls that just always has to have a bunch of friends around. Okay, you know what I'm talking about? They go everywhere together. They're like a pack of wolves. But as soon as a guy shows up, what happens to all her friends? They disappear. Okay, you know what I'm saying. You know how life works. But just remember, anytime you see an S, just write an 8 beside it. So S will never, ever, ever want to be alone. It doesn't even want its twin. It wants 7 more sulfurs around it to make it stable.
Wouldn't we just put it as a trigger on the diatomic bond?
Somebody called it an octatomic or octomic. It's not real, but that makes sense. Okay? But P, do you remember what P had to be? It was P4. Okay? Somebody called that a tetratomic, but whatever. What? All right, please stop. But here's the deal. Let me ask you this. Where did the 8 on the sulfur go once it's now with barium? Okay? No, ignore the coefficient. Where did the subscript go? Why did it just disappear? Why isn't it not BAS8? Every time you write a new compound, what do? Check the charges. Did we have BAS on the reactant side? Nope, it's brand new. We got to recheck it. What group is barium in? All right, so it's a BA what? 2 plus, very good. Sulfur is in what group? 16. What is the charge on all group 16 ions? Very good. So sulfur is a 2 negative. So what's going to happen to your charges? They're going to cancel. All right. So the final formula in terms of its subscripts, does it matter with what metal it's with? Yes. All right. Let's just pick a random one. What if I said it was lead 4? Okay. That's a good question. How many sulfurs did you have over here? How many did you have here? So you had to do what to balance it? You had to put an 8 right there, right? Well, then once, remember, that distributes out, then you have to balance the bariums over here. Exactly. Yep. So you balance at the end.
So what's your
818. In terms of the coefficients. Yep. All right. Now, so what if I said it was lead 4? So it's lead 4 plus, S2 negative. What would the final correct formula be? Why PbS2? Very good, because it's going to reduce. All right. So, you get the point. PbS2. Would that formula be balanced the exact same as BAS? No, it would be different. Okay. Again, you could balance it if you had to. All right. So we're good on this one. Let's move to the next one. Number 4. Put a little star beside number 4. You need to know it as well. Does anybody know what the word halogen means? I'll tell you what. Let me start over. Where does it come from? Very good. Halogens come from group 17. All right. What does it mean? There's a definition of halo. And it's not angel. It's called a salt producer. Now read the statement. Metal plus halogen makes a metal halide. And we'll get down into just a second of somewhere else we'll see it. So a halogen, the definition of a halogen is a salt producer. If you ever take an upper level biology class in college, like organismal biology or biology 2 or anything like that, you'll study some of these organisms. There's something called a halophile, which means it loves really, really salty environments. Really salty. There's some things called acidophiles. What do you think they like? Very acidic environments. There's something called thermophiles. Hot places. Volcanoes, magma, thermal vents on the ocean floor. You only find them in those crazy environments on the ocean. There's some things, and I forgot what the name of it is. Thermo is the heat version, but there is one that likes really cold environments, and I can't remember what it's called. But again, the halophiles like really, really salty environments. So like the Dead Sea and things of that nature, was the only places you'll ever find them. But notice again what happened. We have a metal mixed with a halogen. Now, why do both of these have 2s? All group 17s are diatomics. Now, one other thing that I need you to understand, and you should already know this by this point, what is the charge on all group 17s? Very good. So the charge, we're going to add this in as well. The charge is -1. All right, the charge is going to be equal to -1. It is a diatomic, but it's radioactive, so we never use it.
What did you say?
Astatine, number 8, AT, the very last one of the group. I've never even seen it on an AP problem, ever. So again, it's just one of those weird ones that you don't ever talk about. But are these brand new compounds that we did not start with? So what do we have to do? Check the charges. So charges were checked here. All right, so we checked our charges to do this one. All right, number 5 and number 6 are your two big ones. They're the one that's going to cause you some trouble because you're not going to catch them. Very difficult. All right, 5 and 6. Put a big old star between those two. Okay. All right. Metal oxide. Notice what just happened. Read back at number 1. What did number 1 say? Metal plus oxygen yields a... So this is what we're going to do. We're going to take what we produced in number 1 and do what with it number 5? Add water to it. What is it going to make? Very good. A metallic hydroxide. Now, what is hydroxide? OH negative. Very good. Now, will the final formula depend on what metal you mix it with? Yes, because if it's a group 1, will this subscript go away? Yes. Why? Because, magnesium is a what? So group 2, so that's why that two is there. Any questions here? Real quick. This never mind. We're gonna ignore that. Now, this next one's kind of tricky. Notice what 6 is. Read number 2. What did number 2 say? A nonmetal plus oxygen yields a nonmetal oxide. So we're going to take number 2 and do what with it? Make it water. So, do you agree that carbon dioxide is a non-metallic oxide? And what is it going to make? What in the heck is an oxyacid? Very good. That's exactly right. It's an acid with oxygen on it. An acid with oxygen. It's an acid with oxygen. Now, by the way, this semicolon should not be there. That's my fault. I should not have that in there. Can anybody name that acid? What polyatomic is that? That's carbonate. The 8 ending turns into what? Turns into ick. So 8 went to ick. That's carbonic acid. Very good. All right, now, carbonic acid. Where do you find carbonic acid? In a car. And Coca-Cola. Hannah, squeeze this bottle for me. Just squeeze it. Just squeeze it. I'm not kidding. Just squeeze it. Kind of soft, right? All right, so when I take it, start shaking it up. What's happening? What's the fizz doing? Okay, what is all that fizz?
Carbonic acid.
Okay, squeeze it now. It's a little tighter. All right, so what has just happened inside of this bottle? The pressure has increased, right? Now, you ever seen those Jesus lizards? The one that run across the top of the water?
Yes.
Jesus lizards. Okay, if you don't know they are, Google them, YouTube them. They're cool. Why? Okay, Google them. YouTube it, whatever. Why can they run across the top of the water without sinking? In terms of the water, not them. On top of the water, there's this fine film called surface tension, right? Every solution has a surface tension. Well, they don't fall because of that surface tension. Now, underneath the surface of this water, do you agree that there are molecules running around like crazy things? Now, in this liquid, there is dissolved carbon dioxide. Okay, that's a gas, right? It's dissolved. And it produces this carbonic acid. That's what makes sodas acidic. That's what burns. It tingles. But when I started to shake it up, what happened to the pressure underneath the surface of the liquid in terms of the molecules? It get higher, right? Because they're moving faster and faster and faster. So if you increase the pressure underneath, so if the pressure underneath the surface is greater than the pressure pushing down on the surface, what is going to happen to the molecules that are in the liquid? They're going to escape. So why did the pressure in the bottle get higher than it did whenever the molecules escaped? Now there's more molecules of gas in above the surface that take up the bottle space. Now, what were to happen if I were to untwist the cap? Okay? Now, so release it. Now, if this was a full Coke, I would have just gotten soaked. But the point is that once you release the pressure, you can do it again, and you can build the pressure back up. But again, eventually this thing is going to go flat. What is a flat Coke? Not nasty. When all of the carbonation, now what is carbonation? It's all of that CO2 that has been dissolved has done what? It's left. All right. So again, I've pretty much shaken it up to the point where it's getting there, and you can. I've done it twice, 3 times now, so it's almost getting to the point where it's flat. Matt, stop. Matt, stop. Okay. Was that what that was? All right. But the point is that's kind of what's going on here, and that's carbonic acid in a nutshell. So that's kind of completely off topic, but in a sense on topic to let you know what soda really is. All right, the next one. I have a typo, and I need you to help me fix it. Number 7. Please change this. Cation from an, this should say a base. Please change that. That is a typo. It's a major typo, actually. Change it to say a cation from a base and an anion from an acid. Very good. The cation of a base and the anion of an acid.
I was going to think
My history teacher, Wallace, he was telling us today that one time he was mixing like ammonia and chloride together trying to clean something.
And he made ammonium chloride,
Yeah, and he said,
which is deadly.
What makes that happen? Is it just a mixture of the two?
It's a toxic gas, is what it is.
Trying to clean bathtubs in their base.
Yeah, never mix cleaners. Never mix cleaners, especially in an inside of a house. Yeah, basically if you take a bleach product, which has ammonia in it, and you mix another, like an acidic product, you're in trouble. Get out of the house. Let it air out. Okay. Somebody let her in, please. All right. Now, here's the deal. We need to figure out how this is true. When you see a chemical compound, how can you recognize that it is a base? What must be present? Say it one more time. A hydroxide. Very good. So do you agree that if I wrote this down, you seeing the presence of the OH makes this a base? All right. So if you don't, you need to recognize that now. That if you see an OH with a metal, it's a base. Now, what did our statement tell us, gives us in this? The cation from a base. What is the cation? It's positive and it's always a metal. What is the metal in this formula? Do you agree that this is what we started with? Okay, that's where that came from. Now we need the what from a what? The anion from an acid. Now, this is the particular anion. So what do you think acid it came from? How do you recognize an acid? Very good. That's exactly right. And again, I'm going to teach you this. Some people already know this. Go to number 6 in your packet. That it's acid-base neutralization. We're going to get there. Some people already know this stuff. Now, read it one more time. What does it say? The anion from an acid. So what is the anion there? Chlorine. Is that exactly what we have in our formula? How do you recognize this an acid? What must be present? The hydrogen in an aqueous solution. That's what allows it to be an acid. All right? But notice what happens. We take the anion from an acid, a cation from a base, an anion from an acid, and what are we going to make? NaCl. Is that the only salt on the face of the planet? Thank you. Please write that down. Not the only salt. Not the only salt. All right. So let's pretend that I'm going to give you, let's see. Hang on. Let me think. One more time. It's going to put like 9 of them up there. It's the video is what it is. Okay, so this is something, and I'm going to add it to, I didn't want to say it out loud. All right, and this is our something else. All right. Tyler Reddick, which one of these is the acid and why? Go back and look at your notes. You wrote it down. How do you recognize an acid? It's this one right here. So this is our acid. Now, how do we produce a salt? What part of the acid? Match the A's. The anion, which is negative, right? What is our base? How do you recognize it's a base? All right, so we have OH. So what do we get from the base? The cation. So are we going to produce a brand new formula? What must you always do with a new formula? All right, so strontium is in what group? 2+. Phosphate is? PO4, 3 negative. So you're going to get SR3, PO4, 2. Now, that looks nothing like NaCl, but is it still a salt? Yes, by definition it is still a salt. That's exactly right. Exactly.
Good job, Jordan.
Exactly. No, that's exactly right. And if you will go look at number 6 in your notes, it states it again. Okay. All right. Good news. Put a little X beside number 8. Go ahead.
The HBO, that's made up acid.
It was phosphoric acid.
And then the SR.
That was strontium hydroxide. Okay. All right. Put an X by number 8. This one's just kind of a weird one. A few nonmetals combine with each other to form other compounds. You don't have to know this one. But there is one you have to know. This is the last thing, and we'll shut it down after this. Put a huge star. We have what? Perfect. Okay, because it'll take me 3 minutes to explain this. Put a big star by number 1 down here at the bottom. These two reactions must be remembered, especially number 1. Haber-Bosch. Is it important? Okay, it is very important. I'm telling you now. Haber-Bosch. What is Haber-Bosch? Duh. It is and I want you to write this down, production of ammonia. The production of ammonia. What is the chemical formula for ammonia? Not ammonium. Very good, NH3. Now, what is important about this production of this compound? What do you find ammonia in? Cleaning agents. Anything else? Yes, living organisms. Fertilizers. Fertilizers. Now, what do fertilizers do? Make stuff grow. Now, what's the detriment of these things? Fertilizer bombs. Okay, you mix ammonium nitrate with something and you decompose it, break it up, and it'll blow up and kill you. Okay, because it's going to release a lot of this gas. which is not a good thing. This is one of our biological terrorist threats that we always worry about. People with dirty bombs. Okay, this is one of the dirty bombs we're talking about, these fertilizer bombs. They make them blow up, and it produces a lot of this gas, which is, if inhaled enough, it'll kill you. Think about this. If you are knocked unconscious, they can take this little gas and pop those little things, and it wakes you up out of unconsciousness. If you inhale enough of it, it'll kill you. Okay? You've never seen one of those? One of those ammonia snaps?
No, I mean like it kill you like right there.
No, I mean, you got to breathe a lot of it in.
Can you buy ammonia snaps?
Yeah, you never. People with like trainers and stuff have them on football fields, baseball fields. If you get knocked unconscious, they'll break one open and hold it under your nose, and it literally wakes you up. It's so strong. It's clean water. You're not supposed to inhale it. It's terrible to put over your head. Yeah, don't put it over your head and hang it there. It's okay to like wipe it on your face. Yeah, but what I'm saying, you know, people that sit on the bench and just hang it over their head, and they're breathing that stuff in. Terrible for you. I mean, really, it'll make you lightheaded if you breathe enough of it in.